Okay, now we're going to try to optimize the cylinder. Okay, so same thing. A lot of shapes that we have, right? A lot of shapes, especially for cups or for cans or whatever, right? They have a cylindrical shape, and you want to try to optimize these. Again, to optimize these things, you're basically maximizing the volume as much as you can fit in them, but at the same time, you're using as little amount of material as you can, okay? So when you are dealing with cylinders, the optimal dimension always occurs when the height is twice as the radius. So basically, your height is equal to your diameter. This gives you the optimal shape, okay? With a minimum surface area and then a maximum volume, okay? So where your height is equal to your radius, okay, or is equal to your diameter or twice the radius, okay? Let me start with the formula for the regular cylinder. So what's the formula for a cylinder? From your for the surface area. Plus?
Sorry, 2 pi r h.
So 2 pi r plus 2 pi r h? Yeah. Okay. And what's the volume of a cylinder? That's right. Okay. Now, if I'm optimizing, right, instead of h, what can I replace h with? What's your optimal height? 2r. So basically what I can do is I can take the h right here and right here, and I can replace it with 2r. Okay? So let's see how my formula will become. So I have 2 pi r squared plus 2 pi r times 2r. Okay, because my optimal height is equal to twice the radius. Now, let's simplify this. So that's going to be 2 pi r squared plus 2 times 2 is 4 pi r squared. Yes? Are you okay with this up to now? Okay. So I have 2 pi r squared plus 4 pi r squared. Should I leave it like this? I can add them because they're like terms. So how many pi r squared would I have? 6 pi r squared. So basically the formula that I'll be using for optimization, only for optimization, is surface area equals to 6 pi r squared. Okay? I just showed you how we got to that formula. Okay? You don't have to show me how we get to this formula. This is the formula that you'll be using. Okay? If I do the same thing, so I replace h with 2r, so I will get 4 pi r cubed. Are we okay with that? Okay. So now let's look at some questions. So the surface area of a can of soup is 154.6 centimeters squared. Find the optimal dimension of the can. So what formula do I start with? Yeah, because the surface area is given, then I have to start with the SA equals 6 pi r squared. I'm looking for the optimal, so this is how I know I have to use this specific formula. Okay, so what do I do now? So I have 154.6 equals 6 pi r squared. Okay. Then?
We can divide
divide 154.6 by 6 pi.
Yeah. Be careful that when you're dividing by 6 pi, you put the 6 pi in brackets. Otherwise, your calculator will not know what you are doing and it will multiply by pi. Okay, so make sure that you put the 6 pi in brackets in the calculator. What do you get? So I have 8.2 equals r squared. Then square root. So that gives you 2.9 centimeter. Pi is at the bottom. It's on the times 10 to the power of x. So you have to put shift and that button. Yeah. Okay. So what's the optimal dimensions? What are your optimal dimensions? So the radius of 2.9. So the optimal dimensions are a radius of 2.9 centimeter and a height of So you have to find the height too. Height is 2 times the radius, yes? So it's going to be 2 times 2.9, which is equal to what? 5.8. Okay, so you have to be careful that you're going to have to include both the radius and the height measurement in your question. What are you maximizing here? Or what are you optimizing?
Volume.
The volume. So if I'm going to ask you another question, what could it be?
Volume.
What is the volume? What is the optimal volume? Okay? And then what you have to do is you have to plug in the radius in here. Okay? In the 4 pi r cube. Are we okay with this? Okay? So the volume of a Pringles container is 1800 centimeter cube. Find the optimal dimensions of the container. I'm going to add to this. And find, what would be my question here? Find what? The minimal or the optimal, yep. Surface area. So this is another part of the question, okay? So, and we're going to answer both of these questions. So what formula do I start with? The volume formula, yes. So volume equals to 4 pi r cubed. So the volume is 1800 equals 4 pi r cubed. I divide by 4 pi. Make sure you put 4 pi in brackets. And you're going to get 143.2. And then cube root. And your answer is going to be 5.2. So I have a radius of 5.2 centimeter. What would be my height? So the height is 2 times the radius, which is 2 times 5.2. And that's going to be 10.4 centimeter. So you can write your therefore statement. Therefore, the radius is 5.2 centimeter and the height is 10.4 centimeter. Are we okay with this? Okay. Now the question is, what would be your optimal, the minimum surface area? So remember that the formula for surface area is 6 pi r squared. So I can do surface area equals 6 pi r squared. My radius is 5.2. And that is going to be 509.7 centimeter squared. Okay? Don't forget to write your therefore statement for word problem.